is 7-4, which is nth roots, which is almost the entire thing is already been covered in here, except for one little wrinkle, which we'll talk about. First, though, we have to start with something that we already know. So we're going to do a couple problems like we've already covered to make sure that we're all good. And then we will discuss the wrinkle. First of all, we're going to simplify the square root of 25x to the 6th. To simplify a square root, what we do is we make a tree, a factorization of the term on the inside. 25 is x, or 5 times 5, which is the end of that tree. And the x to the 6th is, well, it's 6 x's. I'll write them out. Okay. And then since we're dealing with the square root out front, or on top of it, we have circled our pairs. The pairs go out, the lonelies stay home. We've talked about all this several times. The correct answer to this one would be 5x to the 3rd. All right, you try this one. Square root of 80, a to the 4th, b to the 5th. Correct answer, we're going to break down the 80 into, well, I end up with 5, 2, 2, 2, 2. I like to write them out in a line so I don't miss any of the ones when they're written all staggered like that. I'm going to write out my letters again. I just like to do that when I'm teaching so you can see how it all lines up. My pairs would look like that. The pairs come out, the lonelies stay home. So each pair has one representative outside the root sign, and the lonelies would be, what, a 5 and a b? And then you multiply those terms outside the root together, so we would end up with 4a squared b squared, root 5b. That's what you need to know. We've already done all that. That's the prerequisite heading into the new wrinkle today. Everybody feel good? Okay. So now we're going to do the cube root of 108 m to the 7th n to the 4th. What's different? It's cube root. What we've done is we've changed what they call the index. The index is what root you're dealing with. We've been dealing with square root. And in a square root, the index is 2. And we don't write an index when it's 2. Just like you don't write an exponent when it's 1 or a coefficient when it's 1, you don't write an index when it's 2. But when it's not 2, you write it just so you can differentiate. So now we're going to be dealing with a cube root, or we're going to be dealing with 4th root, 6th root, 28th root, whatever the problem calls for. Problem goes the same way. We're going to break down 108 into, I'm going to use 9 and 12. You have many options there. Doesn't matter what option you choose because there's only one way to break down 108 at the end. No matter what road you choose to get there, we're all going to get to 33322. Okay. There's only one answer at the bottom for 108s, no matter what path you choose. Everybody should end up with 3 3s and 2 2s. And then I'll write out the letters again. I'm going to stop doing that here pretty soon. So I have that. Now, with a index of 3, it changes what you circle. You don't circle pairs anymore. You circle 3 of a kind. So for something to move outside the root, it's more specific now. It has to be 3 of something. 2 isn't good enough. Whatever the index is, you have to have that many to move it out. If the index is 8, if we're taking the 8th root of something, you have to have 8 of it to move it out. So in this case, we can't circle it unless it's a triplet. There's got to be 3. So if looking at my big list here, it looks like I have 3 3s, a couple triplet M's, and 3 N's. And those are all coming out. One representative of each is coming out front. Everything else is a lonely. The 2 2's, the M and the N all stay in. So if you have a pair, that's no better than just having 1 in this case. They all stay in. So outside would be the 3, the 2 M's, which become M squared, and the N. Those red circles have been moved out front. And then my lonelies inside are in a cube root. Don't forget your index. 4, because it's 2 times 2, Mn. All right. What? Your turn. Actually, I'll do this one with you, and then I'll give you one to deal. All right. So in this one, we're going to break down 32. And 32, and our index is 5, so we're going to have to circle 5 of something. I am not writing out the letters in this one. Okay. So 32, no matter how you get there, is 5 2's. Doesn't matter the path you take, you're going to get 5 2's. So that's good because our index is 5. Now, let's picture there being 15 x's written out, and we're circling groups of 5. What's going to happen? 3 groups. How many left over? None left over. You're going to have to do that with these big exponents. You're going to have to think, how many groups will I have and how many will be left over? You're going to have to do some division kind of in your head. All right? So we have 3 groups of x's. And for the y's, what are we going to have? 4 groups, none left over. So it looks like I don't have any lonelies whatsoever. So I have 2, 3 groups of x's, 4 groups of y's. All right, now it's your turn. Try that one. 729 is 6 3's. So that's coming out. Worked out nice. So you got to think about these letters. 33 x's, circling groups of 6. You would have 5 groups come out. 20 y's coming out in groups of 6. You would have 3 come out. I don't think we have any lonelies coming out of the coefficient itself. But with the x, we would have 3 lonelies. And the y, we would have 2. So there's my answer. Do you agree? Mm-hmm.